welcome to Medical Dialogues, your daily dose of health and medical news. I'm Mr. Zaman and here's what I bring to you all from the world of medicine. Blood tests can detect Alzheimer's neurodegeneration biomarker in blood according to a Pitt study. A group of neuroscientists led by a University of Pittsburgh School of Medicine researcher developed a test to detect a novel marker of Alzheimer's disease neurodegeneration in a blood sample. The biomarker, called brain-derived tau or BD-tau, outperforms current blood diagnostic tests used to detect Alzheimer's-related neurodegeneration clinically. Current blood diagnostic methods can accurately detect abnormalities in plasma amyloid beta and the phosphorylated form of tau, hitting 2 of the 3 necessary checkpoints to confidently diagnose Alzheimer's. But the biggest hurdle in applying the ATN framework to blood samples lies in the difficulty of detecting markers of neurodegeneration that are specific to the brain and aren't influenced by potentially misleading contaminants produced elsewhere in the body. Study finds apparently random baby movements to have a purpose. Spontaneous random baby movements aid development of their sensory motor system, according to new research led by University of Tokyo. If you have spent time with a baby, you will probably have noticed that they hardly keep still. Right from birth and even in the womb, babies start to kick, wiggle, and move seemingly without aim or external stimulation. These are called spontaneous movements, and researchers believe that they have an important role to play in the development of the sensory motor system, that is, our ability to control our muscles, movement, and coordination. If we can better understand these seemingly random movements and how they are involved in early human development, we might also be able to identify early indicators for certain developmental disorders such as cerebral palsy. Mechanism behind storage of remote fear memory by the brain. A remote fear memory is a memory of traumatic events that occurred in the distant past, that is a few months to decades ago. A University of California Riverside mouse study published in Nature Neuroscience has now spelled out the fundamental mechanisms by which the brain consolidates remote fear memories. The study demonstrates that remote fear memories formed in the distant past are permanently stored in connections between memory neurons in the prefrontal cortex or PFC. That's all for today. Stay tuned to Medical Dialogues for latest updates.
Never miss a medical update from Medical Dialogues. Like, subscribe, and press the bell icon.